Alright, so keep in mind these were the problems that we finished off class with in third period algebra. We should have already tried these. Make sure you try them on your own before you go ahead and watch the solutions here. But looking at this, we're supposed to find the slope, and again, we do this a lot of ways. For number 18, we can just pick any two coordinate points and use them to find our slope. So I'm just going to take 15 minus 9 on top over 11 minus 6. Pardon the background noise, we'll hear it off and on here. I got to get this recorded though, so we'll go 15 minus 9 on top, we get 6. 11 minus 6 on top, on bottom, we get 5. And that would be our solution. So 6 over 5 is our slope. For 19, notice our x's are all the same, so it doesn't really matter what's going to go on top. I'll just write something in here for the sake of the problem. Negative 5 minus negative 2 on top, and we're going to go 3 minus 3 on bottom. So negative 5 minus negative 2, we get negative 3 over 0. Again, this is not our solution. We need to keep in mind if 0 is on bottom, our answer is undefined. Okay, if we look at number 20, it's going to be kind of a similar scenario. Number 20, we end up having something that looks like this. We end up having negative 1, whoops, let me get my pen. Negative 1 minus negative 1 on top over, let's just say 9 minus 1. So we end up with 0 over 8, and that gives us a slope of 0 for our solution. Numbers 21 through 23, these are graphing, so again, I don't have a ton of room here. What I'll end up doing is probably putting them all on one graph here really quick. But again, you can always look up more videos on graphing lines and slope-intercept form after this video if you still don't quite get it. Number 21, though, our y-intercept is 4, so I would go up 4, and I would plot a point. So let's plot a point in a different color. So there's 4 on the y-axis, and then my slope is 2, so I need to go up another 2 and over 1. So I would go up 2 and over 1, and I would plot another point, and there's my line for number 21. And it says here also to identify the x-intercept. And we always need to know that if I ever want to find the x-intercept for 21, all I'm going to do is say 0 equals 2x plus 4. And I would subtract 4. And I would get negative 4 equals 2x, so negative 4 equals 2x, and then divide by 2 and solve, and I get x-intercept is equal to negative 2. Okay, the x-intercept on the next one, let's just go ahead and get that out of the way. For plugging in 0 for y, if I plugged in 0 for y, this term would cancel, and I would divide by negative 5, and I would have 2 for my x-intercept on number 22. So 22's x-intercept, I would get x equals 2. 23, again, same thing. I would plug in 0 for y, and I would get my x-intercept at 9. So that's 23. Now to go graphing all those, we have to do a little bit of work. This one, to get it in slope-intercept form, I'm going to do some side work up here a little bit. I need to get a different color. Here we go. So side work. Actually, let's do this. Can I block over that in a different color to make this more visible? Ooh, that's not a block. Oh well, I need to make this a different color so you guys can see my work. Let's go with a box. There we go. Bear with me. Here we go. So if I add the 5x to the other side, I get y equals 5x minus 10. And my x-intercept would be negative 10. So down here at negative 10, and I would go up 5 and over 1. So my line would be steep, and it would look like that. Then for the other one, I would take this term, and I would subtract x from both sides, and then I would divide by 3. So I'd get 3y equals negative x plus 9. And I would divide each side by 3, And so my slope would be negative 1/3. And my y-intercept would be, now if I divide that by 3, it would get 3, so plus 3. So I'd have positive 3 for a y-intercept on number 23, and I'd have negative 1/3 for a slope. So here's positive 3, and then I'd go down 1, right 3, about right there. Okay, and so there's the line for number 23. Again, it's kind of a rough sketch, but you guys should have been able to follow along with that. Okay, so with the notes that we've taken over this section, you should be able to pause and see the answers for this particular set of problems, and all you need to do is describe the transformation from f to h. Again, f of h is up in the, or f of x is 3x plus 4, and that's all there is to it. After that, we just need to take the function and translate it in a certain way. He's fine. Okay, so if we look at number 25, again, pause this video and make sure you get these right. But if we look at number 25, we have x plus 3 on the inside. That's going to shift our graph to the left 3. So that's the transformation for 25, left 3. For x plus 1 on the outside, it's up 1. So you're going to take that whole graph and shift it up 1. This line right here would be a y reflection when it only changes the inputs. You're going to change your y. It's going to be a y reflection. And this is going to be an x reflection because it's going to change our outputs. Okay, this is going to be a vertical stretch by a factor of 3. This would be a horizontal shrink by a factor of 1/6. Again, it's always inverse. Okay, this last one, we have a couple different transformations happening to it here. First of all, notice that not both things are changed to 5 here. So what happened first was a vertical stretch of 5. Then after that vertical stretch of 5 happened, we have a vertical translation of up 1 also. So that would be what you would put for an answer on this, is a stretch of 5, vertical stretch, and a translation up 1. Okay, again, absolute value functions are the same, just if we are graphing them, we would graph the parent function and then move things around. You're not going to get an absolute value function where it's not the parent function. So you have the y equals f of x, or f of x equals absolute value of x, and let's draw that real quick here just so that we can kind of see where these would move. So my parent function would look like this. Let's just say that that's f of x. Okay, and then after that, what we would do is look at the transformation. So if I were to do plus 6 on the outside, we would take this and we would shift it. Instead of at 0, 0, it would be at 0, 6, and then it would go this way and this way. Okay, if the shift is happening on the inside and it's negative, we're going to take the vertex and we're going to shift it right 4, and then we're going to go this way and this way. So that would be 33, would look like that. Number 34 is a vertical stretch. So again, it stays at the origin and it goes like this and like this. It's a stretch by a factor of 4 when it's on the outside vertically. And when it's on the outside here, it's a vertical shrink by a factor of 1/4, but it's also a reflection across the x-axis. Since it's negative, it's going to be flatter and it's going to open down. Okay, don't worry about number 36. I'm not going to give you any in this chapter like this. Let's wait and pace ourselves a little bit, but this would be okay. G of x's transformations right here, when it just says to describe them, we have lots of stuff going on here. First of all, let's talk about this. We have to do this first. We have a vertical shrink by a factor of 1/3. Okay, then we would take that graph after we would shrink it. So here's what the shrink of 1/3 would look like. And after we did that, what we would do is we would shift it to the right 1 because it's negative, so we're now looking like this. And then after that, we would shift it down 2, so now it looks like this. All those shifts help and kind of contribute to what we end up with a final result. Again, we're going to take a test on Thursday. I recommend, if you still have issues over this stuff, type the settings into YouTube or just email me questions and I'll see if I can't help you via email. I apologize for being gone. I'll be at the doctor tomorrow. tomorrow, and we'll see if we can't get things figured out for the test on Thursday.